My name is Itamar Orlandi. I lead the Frontier Power team at Bloomberg New Energy Finance. Frontier Power covers, amongst other things, our research on microgrids. And I have the honor and the pleasure to have been invited by Envy to moderate this session here on microgrids today. So I hope you'll be looking forward to this session. Before we start, I wanted to spend a few minutes to talk about microgrids. If you can get my slides up as well. The reason is actually I was quite surprised that the term came up at this conference much more than it usually does, but I like to spend a few minutes to talk a little bit about what the term means, not because most people haven't heard the term, but because in my experience it still means a different thing to everybody. So within the region here, quite often what we think of is the business case of Indonesia, of the Philippines, island places. You have an island, you have a small community there. It's not economic to reach them, so people put a diesel generator there instead of an underground cable. So you have these very simple residential loads and diesel generators. Increasingly what we're seeing with the cost of solar and now storage as well is that people are saying, well, actually, we can hybridize that. We can bring down the cost of generation. Diesel is one of the most expensive forms of power generation. Let's hybridize that. So you might have this hybrid microgrid where now you need a smarter control system because you need something that communicates between the diesel generator. Now we have solar, you don't need to generate. Now you need to kick back in. Now we rely on the battery. When you take that similar framework, but actually you can think of a larger site, all of a sudden think of a site that is a mine. Now we look something like this. We have an industrial load. We maybe have some workers' accommodation, and we can have a much more sophisticated system. We probably have a gas turbine, maybe a CHP, instead of just a diesel generator. We can add wind. We can add a much more complex system. Now we're talking megawatt scale systems. Once you're there, really, you want to add a more sophisticated communication layer on top of that as well. And you want a more sophisticated human-machine interface, maybe remote control, and you want all of these devices to optimize on a much more sophisticated level because there's more margin you can squeeze out of that. And then when you think that a little bit further, actually, you might have worlds that look very similar, but happen to be grid connected, either at the end of a very long line or actually within a much tighter system. So this you can think of a campus or a business park where you have that same combination of multiple residential areas, multiple commercial or office buildings, different loads, but you're actually grid connected and you're optimizing not just what you're doing within the microgrid, but you're optimizing also what you're doing between the microgrid and the broader grid itself. You might participate in markets. So that's sort of the breadth of what we cover within microgrids. Within that, we can think of different, why are we even doing that? So microgrids generate different types of value depending on where they are and what they're doing. And that can really range from actually value that is delivered to the grid, to the larger system. You might be able to defer investment if you can, instead of widening the line to a remote location, you can actually do more of the balancing there. You can leverage these distributed resources to actually derive ancillary services to the grid, or you can, what is perhaps a more classical use cases, you can simply generate savings and boost efficiency and reliability to the actual site. So there's various value streams delivered depending on the exact configuration and depending on the markets that we have. Why is this even important? Based on our own modeling, we're seeing what we call the decentralization ratio, so the percentage of capacity that is basically going to be installed behind the meter will tend to go up. In the usual suspects, such as Australia and Germany, this is going to go into up to the 40s, so very, very high ratios. But it's not just those places. You see places like China, like Thailand, like Brazil on this map as well. So it's in many places. And that has been driving the conversation. When we actually look at what is happening on the market level, and we map announcements of microgrids with at least 100 kilowatt of renewable capacity, we see this is a very nascent market still. So on the one side, huge potential, very much aligned with sort of the general trends of where the energy system is going, but really very, very sort of one asset a week perhaps that is announced, so very nascent market. Bringing it back a little bit into the region here, we looked recently at microgrids within the Southeast Asia region. The conclusion from that exercise was, you can see there are a small number that has recently been actually commissioned, and also a number of assets that are in the pipeline. The conclusion there was that with a little bit of luck, we may see another wave or a more successful wave within the region, but this is still far from granted. So that's one of the questions that I want to take to the panel now. Before we kick off with this, let me quickly introduce the panel. We've got right next to me Li Chen, who's a consultant at DNV. Next to him we have Christophe Comte, who's with ENGIE in Indonesia. Then we have James Hunt from our hosts, from Schneider Electric in Australia, who's developing the microgrid business there. And then lastly, we have Amit Patare, who's a program director at the NTU University here and the microgrid demonstration project there. Thank you very much for joining us today. So Christophe, I'd like to take it first to you. I know you've been doing with ENGIE a few projects in Indonesia around microgrids. You know, how, from your experience, how aligned are you with that analysis or that conclusion that we said? What's it going to take to see that next wave be more successful than the past waves?
Yes, Itamar, thank you for your questions, and thank you for this introduction, which is an excellent summary of where we are today in terms of Southeast Asia and Indonesia in particular, where I'm sitting. We have made announcement for a number of projects, whether these were hybrid projects or rural electrifications. This was a little more than a year ago, and we still are looking at this as prospects and not really implementation. So we don't see a widespread development of these microgrids, even if we are completely convinced that this is the energy landscape of the future. And this is exactly the core of what we are discussing over these last 2 days here, which is powering and digitizing the economy. So we see hurdles in Indonesia, which are both, I would say, in terms of being able to have decision makers sharing this vision of what is the landscape of energy in the future. And of course, linked to that, a number of reforms for the regulation and the policy framework which should be introduced to enable these developments. And we also see that probably we need, beyond sharing the vision, we need to have also a number of enabling factors, like having more capability developed locally for engineers and companies to accompany this development. It's not simply MNCs coming to Indonesia and announcing that there are fantastic technology providers which would solve the issues. It is really having the capacity to develop the whole ecosystem. And then, of course, we have the communities and the industries which are eager to see these changes, and which are not necessarily also advocating the need for these changes. So we see the need there, but very slow development pace.
Thank you. Lee, I think you've done similar work or somewhat similar work focusing on the other big island and energy access market in the region, on the Philippines. Is the experience there different?
Right. In fact, in the Philippines, the situation is quite similar with Indonesia. And in fact, in the overall picture in Southeast Asia, we have many islands which have island grid. And by default, it's de facto is actually a microgrid, but lack of renewable components, right? And as a isolated grid, they need be self-balancing. And at the moment, most of these island grids rely on diesel generation or heavy fuel oil, making the electricity price about 10 to 15 US cents per kilowatt hour, which is actually a bit higher, 15 to 20 US cents. And today with the technology of solar and wind, you can bring down the LCOE down to 8 to 10 US cents, which makes a lot of sense actually to put renewables into the system. But there's also a problem for the in terms of scale, because microgrids are generally ranging from a few megawatts to a few tens of megawatts, considered as a very big one. And so they have to balance by themselves. They need a load forecast, they need renewable forecast, and they need real-time automatic generation control. When a significant portion of fluctuating renewables plug into the system, there's really a challenge on the ground in terms of both infrastructure and the people, the competence, like Mr. Christoph mentioned just before, the acceptance, right? From the infrastructure point of view, most of the island grids are still rely on manual control. So the operators are trained actually to adjust manually the generators to meet the demand, which the demand pattern they are predictable and they know from day to day. Now their action is too slow actually to catch up with the renewable fluctuations. We need for sure a microgrid control system that can automatically helping those operators to cope with the fluctuating renewables. This is the first thing. And for people's side, they are mostly chained to existing system. When they see the high fluctuations, they are naturally scared about accepting more renewables into the system. And once they are scared, it's difficult. They put a very small quota that make it difficult to make the project viable.
I want to. That's really interesting. I want to take that apart a little bit, right? So when you say that, there's sort of the technology side to how much renewables can you actually integrate sensibly, economically, technically into a system. But what you're saying is there is also an element of sort of the organizational side of that, and perhaps the willingness to take risks or limited risks to test new technologies. First of all, maybe to both of you, dive in. Do you see a change in that sort of mindset? Do you see is there an increasing willingness on the ground to take that? Maybe Christoph and Lee on the ground in Indonesia and the Philippines.
I think there is not a big and strong will to make the change. I think in Indonesia there is a lot of inhibition in going renewable. There are unfortunately a few counter examples where first projects were difficult to dispatch. There is a case of a 5 megawatt solar plant which was installed in Kupang, where actually the dispatch was very difficult to reach the nominal value. I think Lee can expand on it. And so we are in Indonesia discussing with vertically integrated utility, which is a monopoly from Aceh to Jayapura. And the integration of renewable, which has happened up to now, is mainly base load renewable, i.e. hydro and geothermal, which is in terms of integration much easier. So when we are starting explaining that we are going to integrate into the grid intermittent generation, they don't necessarily have the tools and the big enthusiasm into going into this change. It's basic change management, but the preparation of the teams on the ground is not ready yet, and that's something we are facing all the time when we go and meet the teams locally. Some grab it, and you've got millennia guys there as well who are switch on, but they are not necessarily in power position yet. So yeah, it is a hurdle, as I mentioned. It is to have this vision shared and pass through the echelon and the hierarchy of the organization.
And then, thank you, Christophe. And then, Lee, the other side of that is the organizational willingness, but the other side is the technological willingness, right?
Right. In fact, the dispatcher on the ground, when you go to a small island, you are not, expecting that the talents, naturally they go to the city centers. And there's really a knowledge gap there. And at the same time, they actually, due to the existing infrastructure, they are not able to predict the renewable generations. There's also no mean provided to them to have a real-time control, automatic control for to smooth the fluctuations. For example, even for a very big one in South Sulawesi, South Sulawesi is 2,000 megawatt system. I think beginning of this month or late last month, there's a 40 megawatt, 45 megawatt power ramp down, and it caused under frequency load shedding, which is if you look at the system at this size, it's not logical, but there's infrastructure, lack of proper tools and infrastructure to manage these issues.
So I mean, one thing that I often hear from developers is basically they say, okay, the economics are there. If you have a site that's running on diesel, you can come in, you can reduce that mix that with PV, but then you get into sort of the more technical nuances. How do you actually manage it? When there's a cloud and the solar disappears within 20, 30 seconds. How do you manage those things? And what the developers say is, look, in the catalogs, everybody has it. But when we want to go and finance a project, then we need to show, is there a track record? Is there somebody who's done it in exactly this combination, in exactly this context? And I guess, James, you're selling some of that kit. Can you tell us a bit more, within the more developed context of Australia, where you want more than just a few hours of power, where you need to be pretty reliable. What are sort of the questions or the willingness in trying these things that you're seeing in the field?
Yeah, look, I think probably a bit of background into the Australian market. We've had, I guess, what I'd term as a diabolical policy situation over the last 10 years. It's pretty much cost the last 6 prime ministers their job. So we've got a situation where coal-fired power is being pulled out of the market or retired, and we've got an influx of renewables coming into the market. That causes some intermittency and challenges. We've also got quite high wholesale costs. So with solar and storage costs coming down, we're seeing a lot more investment in solar and storage occurring in the utility scale, but also behind the meter. That obviously leads to challenges, and so if you think about the changes we've seen, if you went back 15 years ago talking to some of the networks, solar was seen as a potential problem for the network, but if you look at the network transformation roadmap that was released by Networks Australia, they see that customers are going to be putting solar in, customers are going to be developing into microgrids. We're moving from a situation where we have a centralised energy system to decentralised, and the customer has to be at the core of that, and networks have to engage with customers to support and drive that change.
And That's sort of on the back, and I mean, we all know Australia has probably the world's highest penetration rate of rooftop solar at the moment, one of the leading markets for residential batteries. Tell us a bit more, but you're now selling this, I think you said for the last year or two, really under the microgrid label,
Yep.
right? So what is sort of, I think people can imagine the use case in a remote island in Indonesia, but when we think of, an industrial zone in Sydney,
Yep.
or where are these projects? What are the use cases?
Yeah, so we're seeing a lot of investment within the network. So yes, of course, off-grid is a straightforward business case. Diesel is expensive, solar and storage can reduce the cost of that. We're seeing investment at the edge of the grid. So communities that want to put solar in when they're developing a site and therefore have a lower connection cost. But the real boost we've seen is microgrids that are within the grid. So customers are putting a couple of megawatts. So we've seen a shift in the size of solar going in from a couple of hundred kilowatts to megawatts. Customers are seeing that they can put in storage and turn it from being something of self-consumption to potentially an asset where they can generate revenue. The challenge for a customer is to be able to overcome the disaggregation of the value stack. So you mentioned before different sources of revenue. In Australia we have a completely deregulated energy system. So we have deregulated energy markets, we have regulated monopolies for transmission, distribution, and deregulated retail markets. If you're a customer developing a project, you need to be able to overcome that disaggregation of the value stack to be able to get your revenue from your wholesale energy, potentially FCAS markets, so frequency control ancillary services markets, potentially participate in demand response, ideally some revenue from the benefit to the network, although that's inconsistent depending on where you are, and then also managing your self-consumption.
And which ones of those, sort of, if out of that whole catalog, if you look at your projects, how many boxes do your current projects tick?
Different projects will tick different boxes. So with that deregulation and the disaggregation, the keys to those revenue sources are held by different people. So for wholesale markets and FCAS markets, that's held by the retailer. For network support, that's held by the networks. For demand response, that could be the retailer or a third-party aggregator. In fact, the only one that a customer has control themselves is how they manage their demand charges and their self-consumption. So it's a matter of getting as many of those as you can put together in a project. If I use an example, there's a site we've got a microgrid on, Hardwick Meats, which is a meat processing facility in Victoria. They've been able to have a battery installed on their site by the network. The network then has control of that battery. That solves the reliability issue for them. Another microgrid, South Australian produce market, suffered from the blackout that happened in 2016 and lost a lot of stock. So they're a direct market participant, so they interact physically with the energy market themselves, so they're able to access those benefits. And then another project we're working on in South Australia is not a direct market participant and having to interact through a third party, a channel partner we work with, Planet Arc Power, as well as a retail contract, as well as their existing retailer.
Yeah, that's really interesting. And I think just to add to that, right, it's sort of we forget, but the value that you deliver there, I on my slide where I drew the value streams, I didn't put numbers on it, but part of that is the resilience value. When you have a warehouse full of frozen meat, right, you're getting much more for that. It's not that 1 kilowatt hour that you're missing, it's you might have to replace your entire inventory.
Yeah, absolutely. And that's the sort of, that use case would be what drives a customer to have the ability to island. So even though they're sitting within a distribution network, customers have to make the choice. Am I doing a microgrid so that I can maximise self-consumption and don't need to island? Or am I developing a microgrid where I am going to need to island? And that generally requires greater investment, greater controls to be able to facilitate that. So it is a more expensive proposition to be able to island, but for someone who's overcoming a reliability issue or has stock that's at risk, then that makes sense.
Excellent. Amit, I want to take it over to you. You know, we heard a bit what's going on in the field. I'm curious to hear, you know, you're more on the R&D side now and the early stage commercialization side. I want to hear a bit more. A, tell us about your project, and B, sort of what's the R&D roadmap? What are the technologies, capabilities we're going to see in 2-3 years?
Sure. Firstly, thanks everyone. Thanks to Schneider for having us here. So I'd just like to say that Schneider is one of the founding members of a consortium called REEDS. REEDS being Renewable Energy Integration Demonstrator in Singapore, so REIDS. So Schneider together with NG is one of the founding members of one of the microgrids that we have in this program. So maybe I'll just spend a few moments describing the program and what it's trying to do, and then speak about what are the possibilities that we will be exploring as part of the program and then as a successor to that program. So what are the key use cases, what are the key challenges that we are facing that we are trying to meet here. So the REEDS program is on an island just next to Singapore called Semakau Island. And the way the architecture is built is we have got 4 independent microgrids that are connected to each other. And we also have a cluster of 4 more microgrids. So the independent microgrids are capable of having, let's say, 500 kilowatts to 1 megawatt. And then the cluster of microgrids are of a slightly smaller capacity. The beauty of this is that each of these microgrids is different because it's brought with different customers, with different partners rather, and each of these partners is bringing different use cases. So at the outset, when Itamar described the notion of a microgrid being different for different people, some microgrids have solar, some have wind, some have biomass, and then on the demand side as well, you can have some microgrids that are more focused on islands, some focus more on mining towns. So it's a mix of use cases. And what we are creating, therefore, is the opportunity to have a diversity of use cases in different microgrids. So some of our partners are bringing in maybe a combination of solar and hydrogen. Some are bringing in, let's say, wind. Others are bringing in electric vehicles. So we see several use cases in the future. And these microgrids can then either run tests in isolation, or they can even partner with each other, or you can combine these microgrids to run an even bigger test. So that way what we create is essentially mini proxies of all the use cases that have been described so far. So that's the opportunity that we are creating here. We can test different use cases with different demand profiles, with different generation profiles, and therefore be a bit more prepared for the use cases of the future when you have a greater ingress of renewables in the system. Now, why is this important? This is important because of the whole concept of decentralization. Now, there is the story which is often heard by sector people in the UK, for instance, where when you have big events in the UK, so big events like the World Cup or for instance, in the old days when everyone used to log into the same TV channel and see Coronation Street, or when you have the World Cup final for football. At halftime, when everyone stops watching TV for a while and goes and turns on the kettle, there is a huge surge of demand in the system, and as a result, you need a lot of ancillary service capacity in the system. So this is even in the fully built power system, that you have a huge challenge of maintaining grid reliability and grid stability. Now, when you look at microgrids, remote communities, if you have the same kind of behavioral response, it illustrates the challenge of maintaining grid stability and grid reliability. That's a huge, huge challenge, which is not a trivial problem to solve. So even if in a community, in a village where you have, let's say, 100 families, and you have even, let's say, 20% or 30% of these families who turn into a certain kind of behavior all at the same time, for sure that grid is going to collapse unless you have the right measures to manage it. So that's part of what we are testing in the system. How do you maintain the reliability and stability of these grids in a variety of use cases with a variety of generation, demand, and storage profiles? How do you mix and match different components? What kind of equipment do you need? How do you make sure that you allow for some redundancy in the system? So these are all the questions that are being explored as part of the REEDS program. Now, what was mentioned is that sort of responding in real time is a huge, huge challenge, and in fact, that's what is stalling the expansion of the whole microgrid phenomenon, because that's what is keeping investors from investing, from making the business case quite rentable. And that's where we see the sector going in the future, that to maintain grid reliability, to maintain grid stability, what you need is very advanced distribution management systems. So the current distribution management systems don't have the capacity to fully integrate distributed energy resources, like a large component of solar or wind. They don't have the capacity to integrate a large amount of intermittent resources. So that's the capacity that we need to add to the system, and what is in some circles being called as DERMS, DERMS, Distributed Energy Resource Management Systems. So you combine the DERMS with the DMS of the future, and that's what leads you to an advanced distributed management system that can actually maintain the stability of the grid in real time, that can add self-healing properties to the grid, that can make sure that you're creating the platforms, the algorithms, the models, and indeed later on the equipment to be able to manage the grid in a stable operation. So this is absolutely vital when it comes to grids which have a renewables penetration of over 20%, over 30%, in some cases even more, as we see in Germany. So, and this is going to be especially vital for communities which exist in Asia and which will rely on microgrids overwhelmingly. So in Singapore, of course, it's a place where the grid is very well built out, but in communities in Indonesia, in the Philippines, even in Australia, in remote locations, in India, it's really challenging.
So let me jump in here quickly. Sure. I think what you allude to is basically this notion of what's called virtual inertia in some way, right? So we have, I think we haven't mentioned, but in a lot of these cases, we still either have the grid or we have a diesel generator, something that's spinning.
That's right.
But when we think about really, the far future, when you look at the mainstream media, people start to, you get this idea of, now battery prices are coming down, we've plugged the gap and we can just run on solar and storage. On really what you allude to, when you have this fast ramping capacity, are we there yet? Can the controlling technology work on just solar and storage?
No, just with solar and storage, that's not always sufficient, because what people don't realize is that in the current system where you have mainly, let's say, electromagnetic technology, so which rely on let's say the spinning of a coil, and then you have induced current. So that kind of a system, a very stable analog system, is one where in the alternating current system, it's relatively easier to modulate the system and to maintain stability. With solar, with technologies like solar and wind, which run mainly on DC currents. Well, someone's having fun there. Okay. So with solar and wind, those which have DC, which run on DC, they introduce a lot of harmonics in the system, and it's a challenge to manage these harmonics at a very high penetration level. So that is indeed a challenge that will need to be overcome. And it's going to take a bit more than just simple storage in order to be able to do that. So it requires a lot more capacity.
But what I think is a really interesting phenomenon, these problems are the most pronounced in microgrids, right? Yeah. That's where you have to solve it, otherwise exactly. You have no other backup.
Exactly.
But really there are problems that the whole grid is going to face eventually when you're talking about the kinds of decentralized and intermittent penetrations that we're looking forward to.
That's right.
So you can start to think of this notion that actually these microgrid controllers, the same technology that now solves problems on remote islands or mines, is going to be able to contribute its part to actually stabilize the grid.
Absolutely, that's a very good point. And that's why we need these test beds where you can safely test all of these technologies, safely test all of these different combinations of microgrids and make sure that they are running safely before you can introduce them, or before we can be prepared for encountering these problems at a much larger scale. That's true.
Lee, I want to take it back to you. Is that this debate, does that sort of, you've done a lot of technical due diligence of projects. Does that resonate?
At the moment, our power system is still designed with a rotating mats where you store the kinetic energy and so that you have either 50 hertz or 60 hertz. And at the moment, all this whether battery storage system, by the way, can respond really fast, ramping from 0 to 100% in 2-3 seconds. And but we still need a reference. So that's the issue. Unless we have a really, when the battery price become really economic, we can operate part of the storage system on voltage and frequency control. At the moment, all of them are operated in current control. That means responding to the system. They are not actually as a main contributor to give a reference, a voltage and frequency reference to the system. So this will largely rely on whether your battery price forecast will become true or not.
I think that's a really interesting point, just because in sort of, it illustrates really the speed at which the system is changing, right? If you look at, just a few years ago, a fast response time was 10 minutes. You know, you pick up the phone and you make a change. Now you're talking about 2-3 seconds. We're hearing companies talking, you know, less than 200 microseconds.
It's a really good point. So if you think about FCAS markets in Australia, if you went back 7 or 8 years, FCAS markets, no one really paid attention to them because there was a lot of coal-fired generation, a lot of gas-fired generation. There was no revenue in it, and so it was kind of there in the background but otherwise ignored. It was only probably 3 years ago when Playford and Northern, 2 coal-fired power stations, were pulled out of the South Australian market that we lost the inertia, the rotating machinery inertia, and suddenly FCAS became short and the price spiked. So then it suddenly gathered everyone's attention. You will have seen, obviously, the 100 megawatt battery that went in. That's, since it's been in operation, has taken 50% of the 6-second market and dropped the price by 95%. So there's a few instances where the Tesla battery has responded before the request from AEMO has even reached the coal-fired generator to provide the support. So the issue is being resolved before the message gets to the traditional generation to resolve it. And I think if you translate that back to what we're talking about with distribution networks, uncontrolled solar within a network is a liability for networks to try and manage. If you can control them, then they can become an asset. And it's the same for microgrids. If you don't have control of renewables within a distribution network, it's a liability. But if you've got microgrids that you can leverage to support network services, then they become an asset. So one of the projects we're working on at the moment is an integration piece of the microgrid platform with the DERMS platform in South Australia, and we're looking at a project of a similar vein in the ACT to try and demonstrate the value, give visibility for the network operator of microgrids so that they can start to build out how would we use these to manage our network.
It's getting into the kind of response speeds where it matters how many APIs you have in between and how fast the signal can travel. So that's a huge change for the system. Christoph and James, I want to take you back to that notion that we have, you know, if we imagine in, I don't know how many years, a system where basically you have a lot of microgrids that are grid embedded but can do all of these functions. You both represent companies that do a lot of C&I energy services. You know, what's it going to take, you know, to actually go and implement these things on the ground, right? It's one thing to sort of draw the picture here, but actually building those things in day to day and baking them into business models is a different thing. How do you see that evolve?
Just a few words, but I'm sure we've got some very good examples in Australia which can probably lead the market to that. Definitely ENGIE is looking at that very seriously. That's for us very important to be the partner of the RE100 companies and being able to provide sophisticated services to make them more focused on their own business and to handle the energy services and efficiency management of the production of energy and related matters. But we are very eager to participate to these developments. As far as a country like Indonesia is concerned, we are still far away from having immediate prospects because, on the other hand, of course, the distribution and transmission network is still under the hands of PLN, the utility provider. So if beyond next year, if we believe that the next term of the President Jokowi lead to some restructuring of the power market in Indonesia, yes, maybe that will be an interesting conversation, but that's maybe a little far-fetched.
Yeah, look, I mentioned before that the energy policy arena is a diabolical issue in Australia. That's really at the federal level. I must say, on the flip side, ARENA and AEMO have both been very active in supporting demonstration projects, integration of renewables, integration of microgrids, and most of the distribution networks have also been very active in trying to develop and support development of these projects. So that's really, it's a really positive sign, and will really help deployment and development. I guess one of the other areas we see a challenge is around what we call the technology gap between what consultants and specifiers know is possible and what technology vendors or developers like Schneider, like Engie, know is possible. So that gap in technology and understanding can be, in some cases, 5 to 10 years between what we're working on, what's coming into the market, and what the consultants are comfortable with or understand. So we're working to resolve that. I think probably the other thing that will really drive scale is a move from engineered projects to customizable projects. So I guess for anyone that was in Philippe Delorme's presentation yesterday on EcoStruxure Power, he talked about the transition to customised projects rather than engineered projects. And that's where we need to get microgrids as well, if we're going to have any hope of getting to the scale we need to deploy.
Amit, on that note, is...
If I may add a couple of points, I think, I was speaking with the CEO of a company that has established more than 500 microgrids a few days back, and he mentioned that what kills you is not the capex, it's always the opex. When you're operating in remote areas, you can control your capex, and that's all fine, but it's the opex that really kills you. So, and I'll give you 2 examples of that. The first example is that of preventing power thefts. So you may have built your microgrid, but then how do you control your theft? You may have has a diesel there, but the people who are responsible for filling up that diesel are the ones who are stealing it. You may have your villages, which are just, you can have people that simply just tap onto the lines and they can easily steal electricity. How exactly are you going to control for that? So if you just rely on more and more enforcement, so people going around with motorcycles, buying jeeps, and maintaining that fleet to manage the operations, you end up with a scenario where your overheads keep on going up and up and up, and eventually it becomes unwieldy to manage. You can have issues like so there's thefts, there's management of overheads. So all of these issues gradually keep on adding up, and eventually it becomes completely unsustainable. So that's one of the things to manage.
I think that's right. My sense is we could go on and on. James, to have a last word? No. So that's the impression I get. And as I promised in the introduction, it's a super wide topic. So I hope my sense is we only scratched the surface of a variety of applications here. I took down a few notes sort of to summarize the conversation. The overall sense is, James, you put the lag at about 5 to 10 years. I don't want to put down a number, but there is probably a lag of what the technology today is capable of doing, and what we really see in the market. And I think what we're seeing based on the conversation is there are 2 main hurdles. One is the technology cannot do everything quite yet and isn't proven, but at the same time as well, there's just a lag in what people expect or what legacy systems currently can absorb without sort of a willingness to try and integrate new technologies that are economic. At the same time, going forward and solving that, sort of I think that the shift in terms of customizing and doing it in a more reproducible way James, we talked about that yesterday, I think briefly. When you're doing smaller and smaller projects, which is in the nature of decentralization, you simply don't have the margins to customize everything. So you need to have reproducible systems. So there is a bit of looking into the long-term future, probably an opportunity in terms of doing this customization. The other topic in terms of R&D opportunity that we touched upon is really managing at very high renewables penetrations, something that storage today cannot fully do from what came out. And I think with that, we're really with a summary, but just at the very end of the session. So thank you very much for joining us, and please join me in thanking the panel for the excellent discussion.